the same graph. You have T naught, T1, T2. So if you dropped a ball
Put Y max.
from here, you might go straight down until it hit the ground, how long would it take? So let's see, here we said, is this motion, are you gonna have to worry about what's happening in the X? No, it's all in Y.
That's Y.
At T1 we said Vy was 0,
Yeah.
and the acceleration was negative 9.8, and then hits the ground at T2. So here, what would Vy be right before you drop it?
0.
And then your acceleration?
Negative 9.8.
So what time is it gonna, if you drop this one at T1? So you launch this one, it reaches the top, and at that same instant you drop another ball.
So you're gonna land at the same time as the first one?
Yeah, exactly. Because we can ignore what's happening in X, because it doesn't really affect how quickly it'll hit the ground. And so this time T2 minus T1 will be the exact same amount of time it takes for this ball to fall. There's like a picture in the book that kind of shows that. It shows like you've got two balls and one is launched. So one is just dropped and it shows it kind of like just falling straight down, hitting the ground. But the other one is launched out, but it shows you that they hit at the exact same time. So that's what it's showing you, is that even though this one has an X velocity and that one doesn't, it doesn't matter. They both hit the ground at the same time. So the same would go for if you say at time 0, you threw this ball, but you threw another one and just threw it straight up at the same velocity you threw this one up, and it reaches this point and turns around and hit the ground. What time would it reach its highest point?
0.
Well, so you start at T1 and you throw both of them. What time will this be if at its highest point?
Oh, what time?
Yeah, out of these three options we've got.
When it hits T1.
Yeah, and then it'll hit the ground again at T2. So even though you throw one ball straight up and you throw the other one out, if you throw them at the same Y velocity, then they're going to follow the same times as far as Y.
Gotcha.
That's kind of why we can look at X and Y totally separate from each other, because they don't affect one another. So when we're doing kinematic equations, we can do stuff in the X direction and then do some in the Y, and then figure it out from there.
Okay. This one is asking like the answers are like T0, T1, T2, T naught.
Yeah, so
Does that mean like,
it's trying to find, it's just saying that you just drop it from this height. So maybe this would be like, this is 0 seconds, this is like 5 seconds, and this is 10 seconds.
should we do like T1 minus T2?
Well, that would give you 5 minus 10. So instead you want to flip it and do
So T2.
T2 minus T1.
Okay.
So that's like your delta T for this part. So that's T final minus T initial.
So you don't want to have a negative number.
No, not for time.
So what is that? It says that there's more than one answer on this one. T2 minus
Oh, check all that apply. Okay. So you've got options of, what are the options again?
T naught,
T naught,
and there's T1 minus T naught,
okay,
T2, T2 minus T1, and T2 minus T naught, divided by 2.
okay. So we've already decided that this one works
Right.
and that T2 doesn't because it's just too much time. Because that's this full length of time.
Right.
So,
I guess T1 minus T naught would work.
right,
It's
because
the same.
it takes the exact same amount of time to get up to the top as it does to fall.
Right.
So this will work. This one? Yeah, that's just 0.
Yeah, so no.
But then what about this one?
T2 minus T naught, divided by 2, yeah.
Yeah, because that's just your full amount of time divided by 2. So all three of those would work.